For all the people joining us this morning, good morning in North America. For our European colleagues, I hope you're having a wonderful day and a wonderful afternoon. We'll be covering cybersecurity in a very new context this morning. MainTegrity Cybersecurity Framework provides an end-to-end cybersecurity and resiliency solution, which includes all of the steps necessary to protect, detect, respond, and recover to cyber attacks. This morning, I'm joined by my colleague, Gary Euler. Gary is the delivery manager here at MainTegrity, and I look after sales and marketing for the most part. So between the two of us, we'll go through both the functionality of the product, a little bit of background on major breaches and why we built the product sort of the way we did. Then we'll go directly into what does the product do and how does it help you do a better job of managing security in your environment. And then we'll do a little bit of wrap up on compliance, and we'll look at a pre-recorded encryption demo, and then if you have interest, there are some optional live demos that we can show you as we go along. So with that, I'll get started on a little bit of the background here. Mainframes for a long time have thought to have been very secure, and in actual fact, until they were so widely connected into the network world, that was really true. But in the early stages, it was clearly the fact that they were in a vault in the cellar of the operation somewhere and running very much on their own. But as time went on, they got linked to more and more environments, more networks, more instantaneous activity. So we're at a stage now where they're connected to nearly everything, or soon will be. So an attack on Windows or Linux, or an Apache web server or a VPN, can be immensely disruptive in the mainframe environment, because once somebody steals some credentials and breaks in, they can move laterally from the network into the mainframe in a quasi-trusted manner. So perhaps one of those distributed machines that is trusted and has been reliable for a long time gets compromised, but that very trust that is established with the mainframe is the way that the mainframe gets invaded. Another big change is ransomware-as-a-service. These are software companies that build specific ransomware and will tailor it for a specific attack. What they are aiming for is something that is very sensitive and central to the operation. And if it is broken or compromised in some manner, that the customer will be required in order to pay a ransom and move on. So these are very sophisticated tools. It's not a singular attacker in their basement anymore. In fact, they may well be state-sponsored. And it is very important to understand that in many parts of the world, this is now part of the GDP, North Korea being one of the primary examples there. But this is a big generator of revenue. And as a result, the state itself puts more people into that. There are rumors of thousands of people in North Korea, but of course, China and Russia tend to be other major violators as well. If you'd move on, Gary.
Okay.
So how does this manifest itself? Well, ZOS was never designed in order to identify internal threats because we thought once we were inside the perimeter, RACF or ACF2 or top secret, once we were inside that perimeter, we were completely secure and trusted. MFA has helped in that environment quite considerably, but all of these things can be attacked. All of these attack vectors can be launched from a formerly trusted environment. So even MFA isn't enough to keep the bad guys out, although it's a very worthwhile step forward. So internal attacks need to be looked at in the same way as external attacks. But for the purposes of this discussion, I've just looked at the very big attacks that have come in from the outside. One of the first ones that we ran across was Anthem Health. And there's lots of public information about this. To date, it's still the largest HIPAA fine, $16 million. The litigation in this case, because the attack was successful and breached 79 million healthcare records, the litigation went on for 5 years and involved 43 state attorney general. The cost of this is now estimated to be more like $500 million. And the legal and settlement remediation continues to this day, 10 years later. So the legal discussions by themselves, litigation, every day, your lawyer coming to see you to say, how in the world could this get this screwed up? And how much are we going to be liable for? So those are really big issues. The same thing is true of personnel management in 2015. There, it was state-sponsored espionage, and 21.5 million records of the highest security people in the United States were released. We think that's another $500 million dollar problem for personnel management. But you know, last year, United Health was breached, and I think everybody was aware of this problem because it affected a third of all Americans. The outage went on for 9 days, and full recovery, even fullish recovery, took a couple of months. I looked at a recent estimate of the cost, and it is now estimated to be $3 billion. The $2.5 billion estimate was only 6 months old. So it doesn't sound like much going from 2.5 billion to 3 billion, but that's $500 million. So if you'd move on a little bit, Gary, we'll stop talking about what the issues are, about what the instances are, but it is important to understand this. What are the common ingredients? Processes. But processes are laid out in many of the standards that are available. But in many cases where there was a breach, they were unimplemented, untested, or incomplete. And that means there's stuff left hanging. So what you need is automation of those processes. And that's what we bring to the table. So we bring technology in to bridge security gaps, to identify security gaps, to complement SMF recording, which is incomplete and far too slow in the context of a cyber attack. SMF is very current and quite good for capacity planning and those sorts of things, but it just misses information around critical security issues. But probably the biggest failing component is people. So in our solution, we look at all three of these environments because we have to arm people with the best possible tools that allows them effectively to react to a problem in milliseconds or at absolute worst seconds. Slow human response time is an eternity. If an encryption against one of your key databases or data sets starts taking place, even a few seconds can cause immense damage. So we need something that's 7/24 vigilant, something that helps people to solve the problem that they're presented with. In the case that something actually slips through, we also need to help them with recovery. So we need to be able to react quickly and with precision, but controlled by the skilled people that you trust today. Gary, if you would move on. Attacks these days are typically multi-pronged. So we've all heard about multiple backdoors being put in installation of time bombs, embedding of malware, and compromising of backups. That's one kind of style of attack vector, and it happens in most cases. What really stands out, though, is if in my recovery process, I am unable to decide what was compromised, and that's very common in these successful attacks. I don't know which programs, which parameters, which data sets were compromised in the first place. So how can I do a recovery in any reasonable period of time? We work around that problem by identifying exactly what got changed in the hopes that we will prevent a problem from occurring at all. So prevention is so much better than recovery because there's no damage and because we can react to the problem much more quickly. In the case of a database encryption, this is another standard part of a modern attack. And encryption on mainframes runs so fast that even a few seconds delay is too long, and a problem may well have progressed to a point where it's very hard or impossible to recover because there are so many concurrent transactions and there are so many other systems that are partially updated, those kinds of things. The last piece, probably the most insidious, is data exfiltration. There we're stealing data records. And those data records, once they're in the wild, once they're out of your control, they're there and out of your control forever. Using defensive encryption internally is a good way of protecting that. But if that database still in its encrypted form is stolen or records are stolen from it, or records, once they're actually decrypted for use in application programs, if they're stolen one at a time over a long period of time, these things all cause serious problems. And even the encryption can be broken on those kinds of things. So these are continuing major problems. Gary? So very quickly, the process layer has been around for a long time. We know about it, and we've implemented it completely in the cybersecurity framework, which Gary's going to lead you through in the next couple of slides. So we know about process, NIST, PCI, Zero Trust, DORA, they all have parts of it, and there are, of course, many more. But there are common elements. So another click for me, Gary. Then there's the technology. That's what we do for a living. So file integrity monitoring is very important for identifying embedding of ransomware. Because we can look inside the modules, because we can look inside the parameter sets, we can see what got changed. That's ultra important in identifying and preventing the problem before it occurs. But if something should slip through your change management process and be accepted, it can also work in a retroactive manner so that you can see what needs to be recovered. And Gary, again, will talk about our recovery capability and how we can go after those specific elements that were compromised and avoid all sorts of regression that might also otherwise be a problem. But reaction time is ultra important. We talk about instantaneous damage control. That's because we can identify the bad guys in the seconds when they are first operating and stop them cold in their tracks with a suspend process. That means that can't do any more, that task can't do any more damage. That user ID can be turned off so that the damage is stopped in a few milliseconds, in a few seconds at worst. If we do that, then, one more click, Gary, then the people have the right amount of time in order to be able to respond because the damage has been held. So it is important that the damage would be controlled to a very small amount. So in the case of data exfiltration, we're talking about dozens of records, not millions of records, as there are in many of these other successful attacks. But it is important that we combine that people requirement with the ability to recover quickly. And that depends on knowing what needs to be recovered. So Gary, I think that covers me off, and I think you get to talk about the product set.
Okay, thanks, Phil. So CSF, Cybersecurity Framework, where did that come from? So we've rebranded our original product, which was called File Integrity Monitoring Plus, or FIM Plus, to MainTegrity CSF, or Cybersecurity Framework. Why have we done that? Well, currently there are 3 main components in the product, and there's soon to be 4. So it was getting increasingly having more function than just file integrity monitoring. So that's why we renamed it. The original component and the name of the original product was FIM Plus. This is a complete file integrity monitoring product for ZOS. It'll detect changes on files by recreating hash keys based on the contents of files and notifying you if they've changed. This type of technology is required and or recommended by various security standards organizations, including the payment card industry's data security standard and NIST. It really is the best way to ensure that your software components haven't been tampered with and remain in a trusted state. And when a change component is detected, support staff can be alerted via an email or a text, and incidents regarding any kind of detected changes can be opened in most modern ticketing systems like ServiceNow or Splunk and others. We released the early warning feature in 2023, and man, time goes by fast. That's just a little bit under 2 years ago. I think it was in August of 2023 we released it. That's hard for me to kind of imagine that. This feature enhances ZOS security by watching the workload and taking action if something seems to be amiss. We monitor over 40 different things, and so there's just too many to go into in detail here, but there's an overview of a few of the things. We can determine if a user or a program goes from being non-APF authorized to APF authorized. We can determine if someone adds group special to their profile. And we can also take action if someone impersonates another user ID by changing the user ID in the task. For these types of activities, which are really potentially significant breaches, we can let you suspend the task requesting the change so you can perform an investigation. And for these types of things, since we've intercepted the request, we can simply not do what they are asking to do and let the task continue. So you have some options on what you can do here. And this can really give you an idea of what the user would have done if they would have gotten the increased security, so it can give you some insight into what they are actually trying to do. We can also, like Al talked about a little bit, we can detect and suspend tasks which exceed thresholds for potentially damaging activity like encryption, mass overwrites, or mass deletes. The ability to suspend this type of workload in flight gives responders the time they need to determine whether or not the work is really malicious. And if the investigation determines that the work is benign, it can be resumed from the point it was suspended. We can also watch and notify you if someone starts snooping around system data sets like Paramize, ProcLibs, and even APF libraries. And we can do this if they're opening the data sets directly and looking in them, or if they're doing something like a rack-FLD command to determine what authority they have from within rack-F. These types of alerts are threshold based, so you can build a level of tolerance into the monitoring so you don't get inundated with false positives. So data exfiltration detection is currently in development, and we are targeting to have this available in September. Data exfiltration, in my mind, is the nastiest of all ransomware attacks. Once your client data is in the wild, there's just no getting it back. The people who stole the data are criminals, so by definition, they are untrustworthy. Even if you pay the ransom, the data is still in the wild and it's gone. We're really excited about what we're doing here. We're going to be able to detect if data is being transferred off premises. We'll be able to set thresholds and allow production off-prem transfers to happen, but stop unknown transfers by both batch jobs and users. This is going to limit data losses and provide notification that someone is attempting this. Both of these are really important, and Al's going to talk about it in some detail a little later on. The supply chain feature of CSF has been around since the beginning, and with this feature, you can monitor entire application, all of the components in an application as a group, and make sure that nothing's changed. You can also roll these applications out to different LPARs at different times. It enables you to do that, and it keeps track of which modules are associated with which version of an application, so everything remains in the state that you want it. This CSF components will integrate into a couple of key points in your current development cycle, and it also can be used to ensure separation of duties when rolling out these applications. The framework contains a base foundational set of components which enable a lot of the stuff to occur. And so because we have all of these foundational elements, they're available in all of the other components. So it's quite a good architecture for a product that does security stuff of this nature. From a reaction point of view, CSF supports the immediate suspension of tasks exceeding thresholds and resumption of those tasks if you do an investigation and you find them to be benign. CSF also supports automatic cancellation and revocation of users who are exceeding thresholds or performing unsafe work. CSF gives you another layer of control beyond what rack-F or top secret or ACF2 do. Just because somebody has the permission to do something, it doesn't mean they should be doing it. From an alerting point of view, CSF can email or text a support person, open an incident in most major ticketing systems, issue a WTO. You have a lot of options of what you can do. And it also has the ability to integrate with the way your organization works and support the technology ecosystem that exists at your site. All of the functions in CSF are controlled by its RESTful API. We've exposed the functions of this RESTful API through 3 user interfaces that come with the product. We have a batch interface, an IPF interface, and a browser interface. The browser interface is used to review and resolve incidents that have occurred and makes setting up notifications and links to other products much easier. The email or text notifications can contain a link that connects directly to an incident in the browser. This incident record will contain all of the pertinent forensic information so that searching for additional information from SMF or other sources shouldn't be required to resolve the problem. The browser can also be used to initiate a surgical restore at the push of a button. CSF can detect a lot of potentially dangerous cyber activity. Whitelisting is used to enable production work that uses potentially dangerous functions to continue doing valuable work without generating an alert or having their operation interfered with. CSF will collect information on your production workload automatically and help build the whitelist for each LPAR. The whitelist can contain batch jobs, user IDs, and program names. The use of whitelisting avoids false positive detections while providing extra scrutiny on unknown workloads. And finally, the Restore Assistant can be used to generate recovery JCL for any files which have been damaged or impacted by cyber activity. Because CSF contains file integrity monitoring, this can be used following the recovery of damaged files to verify that the files that have been recovered are indeed the files that are correct and the ones that you want in your system. This function, like I said previously, can be invoked by the push of a button on the UI or by a simple 2-character command in the ISPF interface. This tool can be used to invoke the recovery capability of other third-party products. We'll talk a little bit more about this in a couple of slides. From an early warning point of view, it's important to note that the early warning component of this product provides continuous monitoring, continuous prevention. It's different than running file integrity monitoring, which is a scan-based kind of a product. So early warning will monitor your system and your workload 24/7 for different things. We call different things. We do have exploit detection, we have file tampering detection, and reconnaissance detection are sort of the 3 main categories. In exploit detection, we've talked a bit about this. We can detect authority tampering where somebody gives themselves APF authorization. We can detect user impersonations where they change their task to have it be operating under a different user ID. And we can check and see if somebody gives themselves, for instance, group special in RACF or the equivalent in ACF2 or top secret. We also do some detection on file tampering, and we talked a bit about this too. This is overwrite protection, encryption detection, mass deletion detection, and that kind of thing. We also can detect potentially dangerous commands like a setprod command. You can add an APF library with setprod command. We can detect those and let you know if they're going on or somebody's trying to do one. And the reconnaissance detection stuff, we talked a bit about this too. It actually goes threshold based. We can have if somebody goes within a certain period and they try to open a bunch of system data sets that they wouldn't normally open, or if they try to check in RACF to see what access they have to certain RACF classes or data sets, that kind of thing. If they exceed a threshold, we'll tell you about it. So it gives you a whole bunch of insight into what is actually happening on your z/OS system that you didn't used to have. After an attack, determining how to recover and what to recover can be a daunting task. You need information regarding what files were changed and which files may contain malware. You also need to know what files have been damaged so you can come up with a response plan, a comprehensive response plan. There are many, many scenarios, and they could be multifaceted. If your software infrastructure has been damaged, you may want to restore the correct versions from your regular backups. If an online database has been damaged, you may want to restore an image copy and perform a forward recovery so you don't lose any of the online transactions that were run. These days, many organizations are implementing immutable backups. If you want to restore from these types of backups, it's useful to know which ones were created prior to the cyber attack. The ones that were created after the cyber attack may contain the malware and therefore aren't really good candidates to restore from. CSF can help with all of these steps in a recovery situation by providing key information on what has been compromised and damaged. It can even customize JCL templates which can be used to restore the damaged files surgically. So how does it do this? The best scenario is to detect and thwart an attack prior to any damage being done, and CSF can certainly help with that. But if the bad guys do manage to do some damage, CSS can provide some critical information regarding the attack. The recovery assistant will know which files have been tampered with or damaged, either from detecting the changes through file integrity monitoring or through the early warning tamper detection feature. This information can be used to tailor JCL templates and restore damaged application or system files from conventional backup sources like DSS, DFHSM, FDR, gold copies, that kind of thing. The system will automatically select a GDG to recover from that immediately precedes the date and time that the attack occurred. So it's got some smarts built into it. CSF will also tell you which immutable backups were taken prior to the attack and therefore are good candidates to recover from. Further, there are products on the market now, primarily from Rocket, I think, which can be used to recover individual files from an immutable backup. CSF already supports that product from Rocket, which is, I think, called data recovery, but I'm not 100 on that. In any case, CSF provides valuable insight when initiating restore activities from other recovery tools, which also helps you when initiating restore activities and products from other vendors like IBM, BMC, and Rocket. And I think at that point, I'm going back to you, Will.
I believe you are. Thanks a lot, Gar. I mean, every time I listen to you, I get a few new tidbits out of this, so that was terrific. New data exfiltration is the most insidious attack that can take place. And this has really proven to be problematic. In a recent case, it was reported that the customer was ransomed not once, but twice, because the ransomware company stiffed their affiliate, is what they call them, somebody that steals the user IDs and actually makes the attack. The money's collected by the ransomware company through electronic means, and then they do a revenue share. However, in this particular case, the ransomware as a service company failed to pay their affiliate, but the affiliate was kind of clever. They had also done some data exfiltration as well as compromising the operation of the systems. So they went back and asked for a second ransom. And it's still not clear as to whether the second ransom was paid or not. But it is just a lesson that says, as Gary mentioned, once you are attacked and you receive a ransom note, you are dependent on the honor of the criminal involved in order to not re-ransom you, or at least give you a key that works so that you can get back on the air. All of these things are very problematic. However, the worst is if they have stolen critical information, private information, credit card numbers, social insurance or social security numbers, those kinds of things. If they're stolen, you can't get them back, and you will never get them back. And if you pay a ransom, which I would like to remind you is paying people to attack again. The more ransom that gets paid, the more ransom attacks there will be. If we can break the chain of paying ransomers, probably there will be fewer ransom attacks. But in the case of data exfiltration, there is no recovery possible. Once the data is gone, it's gone, and it's not coming back. And if it's encrypted, lucky you, it will make it a little harder for the ransomers to actually make good use of that data. But at the end of the day, once that data has left your premises, it's impossible to get back. The only thing that you can do is either prevent the attack, like we do with some of our reconnaissance checking, like we do with our 724 monitoring. That prevention is absolutely critical and the best possible thing that you can have in place. But if an attack gets started, the only other element that you have is to be able to react so fast that not many records escape the environment. And that means reacting in some cases in milliseconds. In some cases, it may actually require you to react to a very slow moving attack where they're stealing one record at a time. But it is ultra important that you can verify from the network environment when data is moving off your mainframe. And we do that by asking the network to keep an eye on all of the attachments that are in place. So not only do we want to protect you from a new unknown IP address attaching to an application for the very first time. Yes, we do that. But more importantly, if it's an old trusted connection that starts to ask for a different kind of information or starts to ask for a different volume of information, those are the kinds of things that say you need to take action and you need to see this. So in almost all of the attacks that I mentioned, that it comes out that somebody eventually noticed that there was unusual network activity. We would do that in a few seconds, or certainly in a couple of minutes. In some of these attacks, that data leaving the mainframe continued for months. So the vigilance of this is important. The knowledge of what is part of your production system and what standard characteristics of that within your production environment is very important. So it's critical that not only can we identify data exfiltration, we can learn about the production processes and the characteristics of those so that we can initiate a cancellation if we need to, or we can initiate the real-time notification. In the worst case, we'll interrupt and then we'll actually have to restart that transmission because maybe it was something that happens that is a change in processing and you find out that that's something you really want. But by knowing what is normal in your environment, we can know what is abnormal. And that means our integration with other vendor tools makes them more effective, and it clearly makes us more effective. So updates to Splunk, updates to ServiceNow, other tools that are involved already in your environment are the kinds of things that we integrate with. And Gary told you about our REST API environment. That's how we do that. So we think all three elements are absolutely important in this environment because you just have to convince yourself that there is no recovery plan that is suitable once a data breach has taken place. So Gary, if you'd move on for me. That brings us back into the process layer. And what we did with MainTegrity CSF is we took the best elements of all of the standards and processes that are out there. So DORA and NIST and other tools, and we built that into an end-to-end process that supports people, that makes people able to take the right action because they have the right information presented to them at the right time. So we think that this is a key element in any cyber resilience environment. And if something should sneak through in some manner, we're there to help you with recovery. So we focus on both sides, prevention and recovery. Gary, if you'd move on for me. Process layer. This identify, protect, detect, respond, recover. Every cyber expert should know all about those environments because they've been laid out in the standards for years. Another click for me, Gary. So we come along and we add these blue boxes, which are all about elements that are super important in each one of these environments, in each one of these stages in the attack, including governance and being able to ensure that you have the right information, have the right pieces in place. Early warning is so critical, but so is file integrity monitoring. File integrity monitoring is substantially the only way you will ever find out what components were compromised, and therefore the only way you will be able to recover the right components. If you have to go back to a different period in time, you are in a world of hurt. And, you know, the best that you can possibly think is be out for days, maybe longer. One more clicker. But the other important part, which we talked about, was the UI. And although we support different UIs, they all have the same information. Anybody that wants to be on 3270 these days can be. But we think pretty much the GUI-based UI is what everybody uses, including our own developers who grudgingly gave up 3270 and moved to UI-based things because they can get so much more information so darn quickly. And it's end to end. But, we start the information flow, you know, days, weeks, months before the attack might take place. And we end up on the other end with a verify that once we've done all the recovery, your system is back to an operational level that you trust. And all of the pieces in between contact you only when there's something to report. So when you think about what we report, these things are whitelisted. We know what normal is. So we're not besieging you with 1,000 alerts. We're filtering those alerts down to the ones that are abnormal, that are causing problems. So it really keeps people in control of the environment in a way that they can act on the information that's presented to them in a logical manner. So maybe go on one more slide here. So that kind of wraps up what we talk about in terms of cyber security framework. And it comes from our company, MainTegrity. If you're looking for us, try www.maintegrity.com. But the point here is, this is a radical change. And for once, the mainframe is leading this charge. We don't know of any other platform that can be made as secure as ZOS is with MainTegrity CSF layered on top. Who else can freeze offending actors in process and make them wait while you decide whether they're friend or foe? Those are the kinds of things that are very different in this platform. And, I won't drone on about this, but we also understand we're going into an ecosystem that has been developed over time. So we integrate with other tools to make sure that we have a complete solution, not just a solution from the MainTegrity viewpoint. So with that, I'll talk. I'll turn things back to Gary, and we'll have a real quick look at what one of these attacks might look like.
Okay, so we're going to do a pre-recorded demo, and after that, I don't know what time is it. Oh, we got 15 minutes.
15
I think.
Minutes.
Yeah. Okay, we can do some optional live demos after we do the pre-recorded one. So I'm just going to go and click, and we'll start the pre-recorded one.
This demo will show how MainTegrity CSF can detect and stop a data encryption attack on an IBM mainframe in real time. On the left side of the screen, we have an email inbox where alerts to the support team will appear. On the right, there's a TSO session representing how an attacker might operate. The attacker is about to submit a batch job that leverages hardware encryption to corrupt a number of files. Let's go ahead and submit that job. Now I'll switch over to SDSF to view the job's status in ZOS. As you can see, CSF has already detected the rogue encryption and automatically quiesced the process, stopping the attack in under 1 second. In many environments, detection can take hours. This is near instant. On the left, you'll notice a real-time alert has been delivered to the support team's inbox. Clicking on the alert opens CSF, confirming that the job has been suspended. Below, we can see the job name and the user who submitted it. A simple drill down reveals additional details: job name, job ID, and submitter credentials. Support staff can also view the datasets impacted by this attack. Here's a list of the affected datasets. Continuing the investigation, I can check whether this job has a legitimate business purpose. If it's a false alarm, I can simply resume the job. But in this case, it's unauthorized, so I'll cancel it. Switching back to my TSO session, you can see that the malicious job has indeed been canceled. Back in the support interface, since the job was canceled, I can now click into CSF Recovery Assist. By clicking here, CSF automatically generates the necessary recovery JCL behind the scenes. This JCL uses additional tools that restore at the dataset level, pulling from IBM safeguarded copies, Dell snapsets or Hitachi snapshots, as well as conventional backups. Here we see the 5 datasets that were impacted. These are the ones I'll be restoring. All that support staff need to do is submit the recovery job. For demo purposes, I'll skip that step and cancel out. Once done, I mark the alert as resolved. Now the interface shows the incident status as resolved. This case is closed. By automatically suspending suspicious activity in real time, CSF gives support staff the breathing room to investigate thoroughly and take precise, controlled actions, while ensuring no additional damage occurs.
So I think it's important to understand that that suspension in real time. It doesn't matter whether it takes the support staff half an hour, in the morning, to respond to the attack and make the decision whether they should move forward or not. That's really impactful for everybody involved. And when we look at the problems that have occurred in the past and the immense consequences, it's really important that you stop the problem as soon as you can. And that relies more on prevention than reaction. However, reaction and recovery are super important. So when we talk about instantaneous detection of problems, we're also really talking about instantaneous reaction and near instantaneous commencement of recovery. So Gary, maybe we'll just kind of open things up. I think I can see any questions that we have here. I don't have any open questions. I see a chat, and I'll take a look at that. But perhaps you might want to see additional things that we can demonstrate real time.
Sure. So we talked a little bit about the browser user interface. This is it. It has a bunch of function in it. It runs directly on ZOS. There's nothing in between ZOS and this. It's serving it up from a ZOS system. One of the things on the agenda was to do a file integrity monitoring change detection, and so I've got a group of files, and that's how our file integrity monitoring product works. It operates on groups of files. This is a group that I have, and if I want to see what's in there, I can just go in and view it. And those are the data sets, the ZOS data sets I have in there. So if I go back to here, I can just go ahead and I can edit something in here. I don't know, I guess I can pick this one. And I'll add some comment lines and save that. And if I go back to here, I can just go ahead and run a scan on that. So if I run a scan, full and quick, we never really talked about that But we probably have time. This is as good a time as any. A full scan will read the metadata for the file and all of the contents of the file and create a hash key from that. A quick scan just recreates the portion of the key that's based on the metadata. There are some differences in what can get detected, but the change I just made will get detected by either. I can do a quick and it'll do it. If you do a, I've got to move that thing. If you do a update in place, like something like a TSO test command or something like that, you do need to do a full scan on a PDS file, but PDSE will actually detect them with a quick scan. But anyway, I digress. So we've run the scan. It's detected a mismatch. If I click on this little thing, I can see the details for the scan here. So what's going on here? So that's the member I changed right there. If I look at this, it'll show you here. It shows you that I added 5 comment lines, and those lines don't exist in the original. So that kind of gives you an idea of what's changed. I can have predefined a set of instructions that you want a first responder to look at when they're responding to an incident like this. And so this is tailorable to the group of files, to the group of data sets in that thing. So I could put in different sets of instructions for different what we call resource sets and that kind of thing. So this is just the demo one, but we do have a response protocol there. If I look at the access list, this is from SMF, so it's showing you the date and time the file was changed. It's showing you that's actually the L part was modified on. It was modified. It wasn't deleted or added. That's the user ID that did it. And because it was a TSO job, the user ID and the job are the same, and that's the member that was changed. If I came in on IP, there would be a TCP IP address there. So whenever you detect a change, you have in a file integrity monitoring product, you have to take one of 2 actions. You either have to decide that the change file is now the current copy of the file, and so it's correct and it's the production version, or you have to restore it to the way it was before. And we saw this in the CAN demo a little bit, but I'm just going to go ahead and instead of just canceling out of this, I'm actually going to submit this. And I'll do that. And if I go into my scan history and I refresh. Okay, so what's happened here is there's my quick scan that detected the change. And here it's been corrected when I did the restore. And at the end of the restore job, I had a file integrity monitoring job that checked it to make sure that it was the way it was before. And so that's what's happened. So now it's restored. If I go back into here and I look at this, all of those 5 comments that used to be right here that I added are now restored. So that's kind of showing you the whole restore. There were some other things that we talked about. Oh, go ahead.
Just hang on a second. We got
Yep.
got one question that came in, and it's quite typical of our discussions, and it's can you give us a ballpark idea of what the processor utilization due to CSF is? And it clearly matters which functions you're running, but as Gary showed you, the importance of a quick FIM scan is that it can be done in some of our larger customers thousands of times per day without significant impact. So like everybody, we have some benchmarks, but typically I think it's more important to say, what are the production users in the field seeing when it comes to CPU utilization? And they're telling us that CPU utilization A is not a problem. And in fact, they have a hard time finding it in their RMF reports and other reports that they would look at. So we currently have no open issues with respect to performance. And since we suggest some of the things that are a little bit more resource intensive take place, on the weekend or overnight or whenever you're not using peak resources, that can help too. But we're just not really seeing much of a CPU problem.
Yeah, we have customers who literally run thousands of quick scans throughout the day. They do the full scans at a lower utilization period, like at night or on the weekends. But quick scans will detect everything except it'll detect everything in a PDSE, but it won't detect things from updating like Super Zap. I don't know how many people even allow you to use Super Zap anymore or TSO test or that kind of thing.
Production environments, I don't think many of our
Yeah.
customers would allow that.
But they would require a full scan on a PDS to be detected. The other thing, I mean, if you wanted to do some math, so early warning, how does that work? So it actually has a loop that it goes and it'll wake up and it'll run through the loop, and you can define how often you do that. The default, I think, is every 2 seconds it wakes up, and the loop, if it doesn't find anything to do, if everything is normal, it's around 120 instructions. Actually, I think it's around 110 instructions. So you can do the math on how big a workload that is. It's really not much. Now it does do more work if it finds something. I mean, but if it doesn't find anything, it's almost nothing. So anyway, there's that. Does that answer the question? Probably.
So, Gary, we got 4 minutes left. I would just ask, are there any any other questions that you want to raise? Just throw it in the chat, or I'll look at the Q&A here. I don't see any open questions, so I guess Gary, if you want to spend a couple more minutes and show them a bit more, that'd be good.
Yeah, I just did a couple of set prog commands, and so I'm going to go and just go into early warning and show you what that looks like. So it's LPAR based. So here it's I don't know what time it is where you are. Here it's 9:57 a.m. So this is the set prog I just ran. So it's alerted me on that right now. And if I click on this, it tells you that here's it's a TSO user. Gary tried to do a set prog, and I didn't have the syntax right, but it detects the set prog. So the other thing, we haven't really showed is the email notifications. So I probably have a few coming in here. There's the privilege command usage. So it's, we do notify people via email when these kinds of things do. You don't have to do this, but people do. You could just open a ticket in a ticketing tool like Splunk, QRadar, or ServiceNow. And I can't anyway. So that kind of thing. I could show you there's a lot to show in the product. Not sure
Gary,
where.
I think if people want to drill deeper, just go on the website, send a note to MainTegrity experts. We'll set up a customized view with your environment in mind. But I think we've been through a lot of technology this morning. We'd be happy to do a deeper dive with anybody that's interested. This is ready for the most insidious attacks that you can think of. We've worked with some of the world's best pen testers, and they just can't break in. No, we take that a great deal of satisfaction in having spent time with some of the brightest minds in this space, and we think that that's reflected in this product. So, I mean, I'd say with that, maybe we're at the top of the hour anyway. I would like to thank everybody for joining us. We think this is one of the most exciting changes in the entire cybersecurity field. And for a change, it's coming to a mainframe first. So hopefully there's a bright future for mainframes and a bright future for all of us on this call right around the corner. So thank you very much for your time. We'll look forward to talking to you following the session. Hopefully it was worthwhile. I think there's some new things that should stimulate some new thinking.
Okay. Thanks, everybody. Bye-bye.
Bye-bye.